Welcome everyone. My name is Amanda Henley and I'm with Planet Mainframe and we're here today for the virtual user group for IMS. And today's session is Modernizing IMS Backup and Recovery, a strategic shift to cloud storage. I think this will be a great session for us just based on, well, it's going to be a great presentation because I've reviewed it, but also I recall earlier in the year we did some research and I think that the cloud storage story is one we need to be focusing on. I see some familiar faces in the crowd today. I feel familiar faces, familiar names in the crowd today. I'd love to see where everyone is from. If you want to drop your location and job title into chat, that might be fun. Um, and then also, if you want, I'd love to get some feedback from you on what you'd like us to present on, like what topics are of interest to you, like where your need for training is, um, any of that, because we can absolutely reach out and try to cover those topics for you in future sessions. So don't be shy. You can jump into chat. I will type my own into chat in a couple minutes. I am, as I said, managing editor, and I am based also in the South. Nancy, I am just north of Atlanta, Georgia, in a city called Marietta. Um, my contact information is on the screen for you. If you don't feel like putting any of your topic suggestions in chat, you can send them directly to me at ahenley@planetmainframe.com. And for today, you can drop your questions into chat. And Sujata, when would you like to do questions? Are you going to do them along the way or you want to wait till the end? That's up to you.
Anything is fine for me.
Okay,
Yeah.
awesome. Great. So before we get started, I just want to plug a mainframe webinar series that we're doing. It's called, the next session is about accelerating mainframe efficiency, training, and onboarding. So it's a partnership with Pop-Up Mainframe, and we're talking about what mainframe teams can learn from each other. So next session's coming up just, I think, 2 weeks from now. So you can check it out around this time in 2 weeks. Again, call for sessions to let me know what you want to talk about, what you want to hear about, and I want to make that happen for you. Before we close out today, I'll do some announcements of our next sessions so you can mark your calendars and go ahead and register for those. And now I'm going to stop my share and introduce our presenter today. So Sujata Mane is a senior QA engineer at BMC Software. I screen share. Did I stop yours too? I'm sorry about that.
I'll share my screen.
Okay, I thought it would
Yeah.
stick. Um, she's a senior QA engineer at BMC Software with more than 11 years of mainframe experience across development and support roles. She's done technical solutions in banking, insurance, manufacturing, working with State Farm, MetLife, HSBC, and Northern Trust. So we've got a wealth of information here today. And with that, I am gonna be quiet and turn it over to you.
Okay. Oh, yeah. I hope my screen is visible
It
to
looks
you.
great.
Okay. Yeah. So, good morning and good evening, everyone. And thank you for joining this session, first of all. My name is Sujata Mane, and I'm a senior QA engineer in BMC Software and have around 12 years of experience in mainframe industry, which includes development, testing, and support activities also. So I have been recently dealing with the IMS, maybe 3, 4 years around, you can say. And I do have experience in DB2 also. So yeah, today we'll explore how the organizations can modernize the IMS backup and recovery by leveraging these cloud technologies while continuing to use the operational practices they have relied on for years. So, IMS has been the backbone of many mission critical systems for decades. especially in banking and insurance, healthcare, and government sectors. And although the platform itself has evolved significantly, many backup and recovery processes still rely heavily on the traditional tape infrastructures. So this approach has worked well for many years, okay? But then today's business requirement presents a new challenges. So data volumes are growing exponentially. Then we have this recovery time expectations, which are shrinking. And then cyber resilience has become again a major concern. So organizations need a faster recovery and then lower operational costs and stronger protection against the ransomware without disrupting their existing operations. So, this today's session focuses on how the cloud storage combined with the traditional backup and recovery processes can help the organizations achieve those goals. So, we'll discuss about the modernization, the underlying architecture, then implementation considerations and operational benefits, and conclude with the practical example of backup and recovery using cloud. So just to make a note of here, like I work in DMC with the backup and recovery team. So I have taken that example which I have worked on. So that's again a disclaimer. That's just a suggestion, and that's not a recommendation. So coming to this next slide for session objectives and focus. So we can see these objectives on screen here. This first one is improving the resiliency. So today's businesses expect applications to be available around the clock. So 24 by 7, they needs it to be up and running. So whether it is banking transactions or maybe insurance claims, as I said, the sectors earlier, the airline reservations or healthcare system. So this downtime directly impacts the customers and the revenue ultimately. And traditional tape-based backup environments can introduce delays during the recovery because of tape mounts and media handling and physical transportation. So, by leveraging cloud-based backup and recovery, organizations can significantly improve the availability of their backup data. So, cloud object storage offers the high durability, built-in redundancy, and geographic distribution, helping ensure the critical IMS backup and it remains available even during the infrastructure failure or site outages. So, coming to the second point, reducing CPU usage. So we know like CPU consumption on IBM Z directly impacts our software licensing cost. So backup and recovery operations can consume a significant amount of general purpose CPU, and especially in large IMS environments where the multiple image copies are created every day. So one of the advantages of modern backup solution is the ability to exploit the Z processor, Z integrated information processors. So this is just for the eligible processing, and offloading these workloads reduces the utilization of general purpose processors. So this will help the organization to lower the operational cost while maintaining or even improving the backup performance. Now, the next is strengthening cyber recovery. So, cyber resilience has become one of the highest priorities for these IT firms. So, no longer enough to simply, having the backups. So, organizations need that confidence that those backups are protected and then they are recoverable and isolated from cyber attacks such as ransomware. So cloud-based backup solution provide the capabilities like immutable storage or securing the object storage. And again, it is geographically separated copies it will have in case of critical backup data. So these features help ensure that even if the production environment is compromised, the organizations will still have the trusted recovery points available with them. Now, coming to this dilemma, as we have been seeing, right, the legacy system challenges. So, I mean, we have these challenges and we'll see what advantages cloud offers for the same. So, for decades, tape has been the standard medium for storing IMS copies and backup data sets. So, it has served the organizations well, However, today's business requirements have changed significantly. So, the first challenge is obviously the operational complexity. So, since IMS has been treated, I mean, it is a legacy system. So, the system itself is very complex in it. And then managing physical tapes or even the virtual tape libraries, this requires ongoing administrations. And then this include the tape rotation, then media management, offsite storage, retention policies, and ensuring that correct backup media is available whenever recovery is needed. So as data volumes continue to grow, these operational tasks become increasingly difficult to manage. Uh, the second challenge is recovery speed. During an outage, every minute matters. So, traditional recovery often involves the locating the backup media, and then mounting the tapes, then restoring the image copies, and then applying the archive logs. So, this process can significantly increase the recovery times. So, especially for large IMS databases, if you say, or the multiple simultaneous recoveries. So today's businesses expect much faster recovery time objectives. So I hope you have heard these terms when it comes to DR planning, the RPOs and RTOs. So RTO is recovery time objective and RPO is recovery point objective. So, I mean, in short, I can say RTO is maximum acceptable time it should take to restore the system after an outage or a disaster. And RPO is nothing but is the, I mean, it is a data, measure of the data, like how much you can afford to lose. So that is RPO. So now coming to this point, these RTOs and RPOs becomes very critical when it comes to the managing this systems on IMS versus cloud. Now the third challenge is scalability. Organizations are generating more data than ever before. So as IMS databases continue to grow, backup windows become tighter, and while storage requirements continue increasing, then simply adding more tapes and expanding the traditional storage infrastructure is no longer a good approach. So we have this challenge of cyber resilience. So in this also, if we see modern ransomware attacks, they don't just target the production databases, they also attempt to encrypt or destroy the backup repositories. So if backup copies are compromised, obviously the recovery becomes extremely difficult. It is as good as failed. If you don't have a good backup, obviously you cannot do a good recovery or a correct recovery. So this has made the organizations rethink how and where the backup data should be stored. So maybe we can compare that with the cloud technology, what it offers now. So cloud object storage provides virtually unlimited scalability without requiring the additional tape infrastructure. Because the data is stored in highly durable and geographical distributed storage, organizations gain improved resiliency and better protection against the hardware failures and site level disasters. So, the recovery data becomes readily available without the need for the physical media handling, and it also helps to reduce the recovery time. Perhaps the most important advantage is that modernization doesn't require changing IMS application or existing the operational procedures. So instead, we are doing the modernization. We are not completely changing the process. So here, if we see our DBRC environment remains the same, our GCL remains the same, and the operational workflows also remain familiar with the system programmers and operators. So maybe we can say like we are modernizing the storage layer. We are not changing the way the IMS is operating currently. So this has allowed the organizations to adopt cloud technologies with minimal disruptions while achieving the significant operational and business benefits. So we'll go to the next slide. So yeah. So a few points we have already discussed about this point, like why modernize now. So we have covered already few topics we have covered. Now we'll look into few more reasons, like why to go for this modernization. So first point is growing data volumes and escalating the cyber threats. So this perhaps this is the biggest challenge, the data growth. So every year the organizations are processing more and more transactions and then retaining more data than day by day. And then IMS databases, again, they are also continuing to grow. And so do the backup sizes, the storage requirements, recovery windows, etc., etc. So at the same time, the cyber threats have also evolved significantly. So if ransomware attacks, if it attacks, it just don't target the production systems. They are also targeting the backup repositories also. And if the backup copies are compromised, then organizations may have, may not have a trusted recovery point. So this means backup is no longer just an operational activity. This has become a critical component of the cyber resilience strategy, what I can say. And then cloud object storage here helps, addressing these issues and these challenges. So this provides the highly durable and scalable, and also it is this is geographically distributed storage. So it is very reliable, I can say, compared to the traditional methods. So it has the features such as immutable storage and object versioning. This further strengthen the protection against the cyber attacks. Now, next is integrating this natively ZOS. So usually, the big question for customers is like whether the cloud adoption will require application changes or major operational redesign. So the answer is no. This allows the organizations to modernize their storage infrastructure, but while preserving the old and proven operational practices. And the third is reducing the CPU consumption with the zip offloading. So, as we know, we have already discussed previously, like this general purpose CPU utilization directly impacts this IBM software licensing cost. So, backup operations, especially if it is compression or encryption or maybe a data movement. So, this can consume significant CPU resources. So, modern backup solutions, like the CDS, these are designed to exploit this zip processor. This also we have already discussed earlier. So, what does zip processors do actually? By offloading the processing, we can reduce the general purpose CPU utilization and we can lower the cost and improve the overall system efficiency with the help of zip processors. So amount of CPU use is reduced, and yeah, again this varies by workload and data volume and compression, encryption, or maybe your system configuration. So important point here is that eligible processing can be shifted from general purpose to zips, so that will help the improve overall cost efficiency. So that is again a strategic thing I can say. At enterprise level, this planning can be done. What all data and what information you can offload from the general purpose CPU to zip so that the speed and reliability and security is maintained and optimized. The next is preserving the existing DBRC and GCL operations. So, that's straightforward. The DBRC here will remain the same. The JCL remains the same. The image copy recovery functions, they will continue to operate as usual. So, this prevents the implementation risk and shorten the learning curve for the system programmers and operators. So, people won't, they won't feel like, okay, they have been introduced to a very complex and very new system. So that's again a comfort zone, which is good in a way for the people who are working in this area. Then next is, yeah, coming to the main point, core point of the session, cloud datasets. So, yes, now this is the technology that makes this possible, the earlier issues and solutions we talked about. So this is again, CDS is something which does this. So cloud dataset acts as a bridge between the traditional ZOS environment and modern cloud object storage. So we can think of CDS as a translation layer. To IMS, the backup still looks like a standard ZOS dataset. The existing JCL continues to reference the datasets in the same way. The DBRC will continue to register the image copy and recovery, whatever the operation is going to happen, that will happen as usual. So everything remains unchanged, but behind the scenes, however, CDS will redirect the backup data to cloud object storage instead of writing it to the traditional tape or DASD. So this allows the organizations to modernize their storage infrastructure without changing the way the IMS applications operate. So yeah, this is how CDS works. Now we'll look at this architecture diagram now. So we'll walk through this architecture. So starting on the left, we have our IMS database. So these may be any kind of databases like full function or HALDBs or FastPath, anything. So when a backup job is initiated, the IMS image copy is created as usual. And then there is no change to the backup utility or the backup process. So instead of writing the image copy to the tape or DASD, the backup is directed through the cloud datasets. So CDS, what it does here is it will securely transfer the backup to the configured cloud object storage. So the platform will be like AWS S3 or Microsoft Azure or Google Cloud or any S3 compatible object store that works here. And from operator's perspective, if we see this process is transparent, the same JCL, same scheduling, same operational procedures, that will continue to work here. So again, we can see the TCP IP network. Over this, the transactions will continue to happen and the data will flow. But this will not be visible to the IMS side as a different thing. So this is how the architecture on a higher level we are seeing. Now, coming on to, okay, let me go back to the previous slide. Just a second. So, yeah. So since the transactions are running in parallel, we can have a high performance with the CDS usage. Now coming on to this next slide, we have the seamless IMS integration. Now we'll see to this key integration capabilities. So we know this Gen JCL transparency. I mean, this is the capability. So Gen JCL is responsible for generating the JCL used to create the IMS image copies. So with cloud datasets enabled, those same image copy jobs will continue to run exactly as before. So there is no need to modify your existing backup JCL. So instead of writing the backup to the traditional tape or DASD, CDS intercepts the dataset request and then securely streams the backup directly to the cloud storage. So this means that your operation team will continue to use the familiar IMS utilities and again while gaining the scalability and resilience of cloud storage. So nothing changes basically here from an operator's perspective. Then second point is rapid hydration. So creating a backup is only half of the story. The real value comes during the recovery. So when a recovery is initiated, this recovery automatically retrieves the required backup from the cloud storage and restores the data back into the ZOS environment. This retrieval process is what we refer to hydration. So the important point is that this process is transparent and operators will continue use the same recovery procedure, and then cloud datasets automatically handle the retrieving correct backups from the cloud storage, and then this will help the operational reduce the operational complexity, and then it allows the recovery procedures to remain familiar. Then the third point is DBRC autonomy. The third capability is DBRC autonomy. This remains the authoritative source, I would say, for IMS recovery information. So, cloud integration does not require replacing the DBRC or changing its role. DBRC continues to manage the image copy registration and then maintaining the recovery metadata and then recovery processing exactly as it does usually. So cloud dataset simply ensures that when DBRC references an image copy, the underlying data is retrieved from the cloud storage, if that is necessary. So this preserves the proven IMS operational practices while enabling the organizations to modernize their storage infrastructures. So now coming to the CPU economics and efficiency. So this is again a major point when we talk about this modernization. So when it comes to modernization of backups, there's another equally important aspect, this CPU, reducing the cost of CPU and processing backups. So on IBM Z, the CPU utilization has a direct impact on the licensing costs. So more general purpose CPU, if our workloads are consuming, then higher will be our operational expenses. So backup operations are particularly CPU intensive because they involve reading the large IMS databases and performing the compressions and encryptions and validation, or maybe transferring the data to the backup destinations. And much of this work is performed on general purpose processors. So cloud-enabled backup solutions, I mean, these are designed to optimize this workload by exploiting the zip processors. This also we have seen earlier. But again, this matters here. So I have reiterating this point here. So this will allow the significant portion of backup related processing to be shifted away from expensive CPUs to zip processors. So as a result, we have more efficient use of IBM Z resources while maintaining the same backup functionality. And again, the benefits go beyond the CPU savings. There is less dependency on tape handling, then less storage administration, and fewer operational activities. So ultimately, this will simplify the entire backup life cycle. Yeah. So coming to this next slide, pre-installation readiness. So let's look at what needs to be in place before implementing the solution. So we need to understand what is our current environment. The first step is to understand your existing IMS backup environment. So we need to have the answers to the questions such as like suppose which IMS databases are being backed up today, or what kind of databases it will be, whether it is a HALDB or FastPath or full function database or everything together, or maybe what backup utilities are currently in use. Otherwise, again, how large the image copies will be, and what will be the RPOs and RTOs, etc., etc. So the next thing will be verifying that the supporting infrastructure is ready. So again, that includes like a supported mm, what to say, a supported ZOS environment, the required BMC AMI components, the network connectivity to the target cloud object storage, then appropriate security configuration, then whether we have sufficient zip capacity if CPU offloading is planned, then cloud integration is only as effective. I mean, we need to check for that efficacy also for the setup. And then the next will be planning the cloud storage environment. Then this is another important consideration here. So, whether you're using this AWS, Azure, Google Cloud, or any S3 compatible object storage, here, I mean, we should define like the bucket structure or encryption standards, access controls, then retention requirements, and then these decisions should align with the organization's security and compliance policies. Now, security and access, again, that is a major thing to consider. So, access credentials are, I mean, we need to ensure that the access credentials are securely managed. Then data is encrypted during the transmission, and only authorized systems can access the backup repositories. Then logging and auditing are enabled wherever appropriate. Then these controls will help us to strengthen the operational security and cyber resilience. Then again, one best practice we recommend here is starting with a pilot. Rather than migrating every IMS database at once, we will be beginning with a smaller workload. So first we will be validating the backup performance, recovery performance, DBRC integration, then operational procedures, then network throughput. That is also one major point to consider here. So throughput also decides the performance. Then, once the team is comfortable and the results meet expectations, then you can gradually expand to additional IMS databases. So this is, in short, a phased approach, uh, minimizes this risk while allowing the operation teams to build the confidence. So that's how the readiness should be there. So in the slide you see, I have mentioned this prerequisites and system prep, the software setup and configuration, um, based on what we have experienced in our setup. So these are the particular points I have mentioned over here. But in general, whatever points I have explained so far, those things we generally consider. So in configuration, if you see the configure M9 environment properties, worker specifications, and these all things, these are specific to an LPAR. So M9 is an LPAR, which I will be explaining in my further slide. So this is Model 9 LPAR we have taken, for example. So coming on to this next slide, hardware configuration, IODF planning. So, before the cloud datasets can communicate with object cloud storage, the underlying ZOS environment must be properly configured. So, this doesn't usually require the new hardware, but it does require the careful planning and to ensure that infrastructure is ready. So, I mean, on a high level, we'll just see what is IODF. So, IODF is IO definition file. So this defines the hardware configuration for an IBM Z system. So it contains the information about the devices, then control units, then channel paths, and how those resources are presented to the operating system. So think of it as blueprint that tells ZOS like how to communicate with the physical and virtual devices attached to that system. So, while cloud datasets doesn't directly modify the IODF, but any supporting storage and networking and virtual devices, I mean, whichever is required for the cloud connectivity, that must be planned correctly. So, planning for the cloud connectivity includes the required network interfaces that are available, like TCP/IP connectivity, then firewalls, network security policies. So, these will allow the secure communication. Then, bandwidth is also, we need to make sure the bandwidth is also sufficient for the backup and recovery workloads. Then backup performance is influenced not only by the CPU and storage, but also by the network throughput, which I mentioned earlier. Now, storage and device planning, if we talk about, I mean, even though the long-term backup destination is cloud object storage, the temporary data sets, then staging areas and system work files may still use the local DASD. So it's important to verify that sufficient local storage is available for the backup processing and temporary work data sets. if virtual devices or storage gateways are part of the architecture, those should also be validated during planning. Then next comes is capacity planning. Like organization should also estimate uh, for the current backup volumes, then expected annual data growth, then backup frequency, then recovery workload during the peak periods. So proper capacity planning helps ensure that cloud integration continues to perform efficiently as environment grows. Then again, we can also consider this high availability considerations. So we need to consider the answers for the questions like, what happens if a network path becomes unavailable, or what will happen if the redundant network connections are not available, and is the cloud connectivity available from both production and DR sites, disaster recovery. So, and again, can the recovery still be performed if one site is offline? What will happen to that site? So, planning such scenarios upfront will improve the business continuity and reduce the implementation risk. So, I mean, given in this slide is just an example of the hardware configuration. Again, I have mentioned earlier, which we have worked upon. So the device type is 3480. I mean, this will emulate the standard legacy tape device formats, and this will be recognized, and the mount point natively. Then we have these control units. So we have maximum 16 devices per CU, and this will be acting as a logical container. Then for dynamic configuration, yes, it is enabled here. And this allows for flexible expansion of virtual devices and control units without requiring a destructive IPL. So without IPL also, we can do this. Then we have a library ID. This will be a 5-digit unique serial number. So this is very crucial identifier that forms the necessary link between the IODF hardware definitions and SMS software definitions. Then coming on to this next slide, which is core ZOS integration. So I mean, these given are the few steps to integrate the core ZOS with CDS. So first one is GRS, Global Resource Serialization. GRS is responsible for coordinating the access to shared resources across ZOS environment. So when multiple jobs or systems access the same data set, GRS ensures serialization and prevents the resource conflicts. So cloud datasets fully participate in this existing serialization mechanism. So that means the backup and recovery jobs continue to follow the same resource locking and dataset protection rules as traditional datasets. So there's no need to implement a separate locking mechanism. So by leveraging this GRS, the cloud datasets maintain the same operational integrity and concurrency control that customers already trust within their ZOS environment. So in short, you can say the risk is less here. Now, next is tape management coexistence. So CDS is designed to coexist with your existing tape environment. So that means the organizations can continue using tape for workloads that still require it, while gradually moving selected backups to cloud storage. So for this, we need to set up some policies and rules which can avoid the scratching of cloud-based datasets. Now, the third one is DFSMS policy activation. So, DFSMS basically stands for this data facility storage management subsystem. I mean, I'm not sure how many of you are aware of this, but on a high level, I can just explain this. So this is IBM storage management framework for ZOS. So think of this as the intelligent storage manager that automatically decides where a dataset should be stored, then which storage class it belongs to, or how long it should be retained, whether it should be migrated, backed up, or archived. So without this, DFSMS users would have to manually specify the storage details for every dataset. which can become a big headache. Then this ACS stands for automatic class selection. So we have ACS routines set up in our systems. So ACS routines are small programs basically that are executed whenever a new data set is allocated. So their job is to automatically assign the storage class, management class, data class, and then storage groups to that data set. So maybe I'll just give an example here. So suppose IMS is creating an image copy dataset named ims.prod.imagecopy.data1. So when this dataset is allocated, DFSMS, what it will do is it will immediately call the ACS routine, and the ACS routine might say if DSN starts with ims.prod.imagecopy, then give storage class equal to cloud and management class equal to cloud retention. So like that. So instead of writing the dataset to the traditional DASD, DFSMS routes it to according to the assigned storage policy. So with cloud datasets installed, that storage class may represent a cloud dataset. So the image copy is ultimately returned to cloud storage. So this is how it works. Now coming on to this next slide, we have a term called pseudo volume engine. So pseudo volume engine acts as an intelligent layer between the ZOS and cloud object storage. So from the perspective of ZOS, IMS, DBRC, and backup utilities, so everything still appears to be standard ZOS dataset. But the application doesn't need to understand the cloud APIs or the object storage, then buckets or REST API protocols. So instead, the pseudo volume engine translate those traditional dataset operations into cloud object storage operations behind the scenes. And this is important because enterprise applications have been developed over the decades and they are using the standard ZOS dataset interfaces. So rewriting those applications to communicate directly with cloud storage would be very expensive, and again, it will be very risky also and time consuming again. So this is something very helpful thing we have when it comes to CDS. Now coming to the immutable cyber resilience. So today, organizations must also prepare for cyber attacks, then particularly this ransomware. So one of the first things ransomware attempts to do is, encrypt or delete the backup copies. So if attackers can compromise your backups, the recovery becomes extremely difficult. So that is why the modern backup solutions must provide this cyber resilience. So for this, we have the worm policies in place. So worm stands for write once and read many. So once a backup is written to cloud storage with worm protection enabled, it cannot be modified, overwritten, or deleted until the configured retention period expires. So this means that even if an attacker gains the administrative access, they cannot alter or encrypt those protected backup objects. So think of it as creating a digital vault for your IMS backups. So once the data is placed inside that vault, it remains protected and available for recovery. And then this gives the organizations the confidence that they always have, a trusted recovery point. So this way, I mean, this is a major thing to have when it comes to CDS. Then we have air gapped recovery. So traditionally, an air gap meant physically removing the tapes from the data center and then storing them in an off-site vault. So cloud technologies achieve the similar outcome through the logical isolation. So instead of depending on physical separation, the backup repository is isolated from the production environment using a separate storage account. And again, it will have its separate own credentials, network controls, and access policies. So this significantly reduces the likelihood that ransomware can compromise both production systems and your backup copies at the same time. So, okay, let me, in the event of cyber attack also, Organizations can establish a clean recovery environment and restore a trusted backup data without bringing the malware back into the production. Now, the third point here is end-to-end encryption. So, security must be maintained throughout the entire backup life cycle. So, that is the utmost part of the life cycle. And then data is encrypted while it is transmitted to cloud storage, and this remains encrypted while stored. So cloud datasets support this AES 256 encryption, which is widely recognized as enterprise standard encryption algorithm. So at the same time, access to the backup data remains governed by existing mainframe security controls like RECF. And then it means organizations continue using familiar authentication and authorization mechanisms while extending the backup storage into the cloud. So together, they all ensure that organizations always have a trusted and recoverable copy of their IMS data, even during a sophisticated cyber attack. Now, coming on to the next slide. So we have this centralized hybrid vault management. So it comprises of three points here: centralized UI, then REST APIs, and then US command level interface. So the first capability is the centralized GUI, graphical user interface. So instead of logging into multiple systems or manually checking backup status across different environments and different LPAs, etc. So administrators, what they can do is they can have a single pane of glass to manage the entire backup ecosystem. So through this interface, they can monitor the backup and recovery activity. Then they can view the cloud storage utilization. Then they can check the job status and health. Then they can also monitor the replication and synchronization. And they can review the retention policies. They can identify the failed or incomplete backup jobs. So every status will be shown on this dashboard. So this centralized visibility simplifies the daily operations. So next is REST APIs. So modern IT environments, they rely heavily on the automation. So CDS exposes this RESTful APIs that allows organizations to integrate the backup management with their existing enterprise automation platforms. So, for example, maybe organizations can automate the backup provisioning, then policy updates, status monitoring, reporting, then alert generation. So these APIs also integrate with enterprise schedulers and orchestration tools such as Control M or Autosys and CI/CD pipelines, etc. So this allows the backup operations to become the part of the broader enterprise automation workflows instead of something isolated thing, some isolated manual task, I would say. Then next we have is USCLI. So while graphical interfaces are useful for day-to-day administration, many system programmers prefer the command line automation. So USSCLI enables this administrators to perform the cloud management task directly from ZOS Unix environment. So this allows the scripting of repetitive administration activities such as creating or updating cloud configurations, or maybe bulk administration, managing the vault policies, or maybe some automation through shell scripts, or some integration with the operational procedures. So overall, this reduces the administrative complexity while improving the operational visibility. Now coming to this next slide. So we have, we have this graph which shows the recovery time objective gains when it comes to physical tape, or when it comes to virtual tape, or when it comes to CDS. So when a critical IMS database becomes unavailable, every minute of downtime impacts the business operations. and customer experience, or maybe potential revenue. I mean, it affects almost everything. So that's why reducing the recovery time has become a top priority for many organizations. So the slide is comparing these three recovery approaches. So, if the database becomes unavailable, then every minute of downtime is affecting thousands of the customers. So, with the traditional tape-based recovery, the operators may spend a valuable time locating, mounting, and then reading the backup media before the recovery begins. But with CDS, the backup object is immediately accessible through the cloud vault and allowing the recovery process to start much sooner, as soon as possible. So this depends on, again, this will depends on the total size of the database and then system resources. And yeah, the eliminating the media handling delays can make a significant difference here. So that's what we see in this graph. So now we have some major vendors in this area which are providing this IMS backup and recovery solutions. So we have BMC Software, we have IBM, we have Rocket Software, Broadcom. And then these vendors, I mean, they offer the dedicated IMS, enabled backup and recovery solutions. So there are some other vendors also, but they may provide the storage hardware and general ZOS backup tools. But they do not offer the purpose-built IMS backup and recovery products. So if you see here, BMC offers BMC AMI backup and recovery for IMS, which includes the image copy, then change accumulation, recovery manager, then recovery and recovery advisor. For IBM, they have their IMS recovery solution pack, which includes the recovery expert, IMS database recovery facility, high performance image copy, and fast recovery, etc. Again, for Rocket Software, they have Rocket Mainstar database backup and recovery for IMS. For Broadcom, it is management solutions for IMS. So yeah, these are the, again, highlighted are the key strengths for each of the vendor. Okay, so coming to this next implementation strategy. So we have discussed few of the points in the slide earlier also, like we will be having the pilot phase first. So I mean, we'll be explicitly routing the specific batch jobs using the unit equal to cloud instead unit equal to tape or dash D parameter in our JCL for the initial testing and throughput validation. Then we will be checking for the ACS programming also. Then, yeah, for ACS testing, use the ISMF to test your DFSMS ACS routine. And then we need to verify that the datasets are being routed correctly to cloud datasets before enabling them in production. Then the next step will be broaden the routing. Then once validated, we'll be activating the ACS policies. And from this point onward, the eligible IMS backups are automatically directed to cloud datasets without changing the application JCL or operational procedure. And the last step will be decommissioning. So finally, as our confidence grows, the gradually will be gradually reducing the reliance on the legacy VTL infrastructures, and this will help us to lower capex and opex both while maintaining the smooth transition. So the key takeaway here we can say is CDS supports a phased and low risk migration. So you validate each stage before moving on to the next, and then allowing the modernization without disrupting the day-to-day operations. Then, as I said earlier, because I have exposure to these LPAR. So I'm taking this LPAR as an example to show how we have seen the performance for the cloud datasets and the legacy tape system JCLs for backup and recovery. So, in this screenshot, what you see is the model 9. This is an LPAR, and we have the started tasks for cloud. So, CDS is enabled on this LPAR, and highlighted are the started tasks here: M9 agent, then M9 ENV, and M9 CDSWK. So, CDSWK is nothing but the CDS worker task. So, this basically deals with the IO operations, the throughput it will measure, and yeah, it deals with the IO operations majorly. So these three started tasks needs to be enabled first on that. If CDS is installed on that particular LPAR, they will be having their own started task, the agent and the worker. These are the two main component, and then the environment. So you need to look at these started tasks first, whichever product you are installing for the CDS on that LPAR. So make sure these are up and running. These should be in execution. So once we confirm that the started tasks are present, they are up and running without any problems, then we can run our backup and recovery JCLs, and we can see how the data is getting, routed to CDS. So here we have this image copy job. So here we are using this program as ICPU main, which is BMC utility for image copy. Again, no recommendation, no advice, because I have exposure to this utility. I am just taking this an example. So this program will run the image copy process. So as you see here, we have the load libraries present. We have given the IMS and recon details. And then in the ICP sysyn card, if you see, we have highlighted this unit as AMI CDSX. So this unit identifies, or it shows that which unit you are using, basically, whether it's a tape or DASD or it is a cloud. So this specific name refers to the CDS. So with this name, you can identify the data set which will be created, the backup which will get created over here will get routed to CDS. So we have mentioned here the model name, and then we have provided the DSN also, and the ampersand parameters. If you see here, the utility is designed in such a way that the DBD and the DSG names will be picked up automatically from the utility. We just need to give the DBD name and then the model name, and we need to enable this DBRC. So this is how the setup looks like for a backup job here. Then once we trigger this job, we can see in spool that we have this messages coming up in the spool. So I have highlighted few lines over here, so which shows up like the particular messages starting with ZM9. So these are the CDS messages. And if you see, the messages starting with plus BMC are the BMC routine messages. So with those particular messages also, you can identify from where the message is getting generated and what is causing, if it is causing any issue. With that, you can confirm if it is a problem with your environment or your utility or the CDS side. So we can see this opening output cloud dataset on unit and then volume. So this whole information, it will show up here, what volume and units are used and what is the dataset name. And then also, if you see on the second line, this volume MDKX0 is ignored. I mean, this volume name, if it is starting with M, I mean, the enterprise level setting is in such a way that we have, sorry, the enterprise level setting is in place in such a way that if it is the volume name is starting with M, we are identifying this is a CDS volume. If it is starting with N, then it will be a tape volume. So this is how you will be able to see the messages, and you will be able to confirm the data is getting, the backup is getting routed to CDS. Now, same is the example for the recovery job. We have this utility RVPU main, and then we have given our parameters here. The same, the same data set recovery will happen with this job. And for the spool, again, you can identify with the same messages starting with Z and BMC. and the other, informational or error messages likewise. So we are doing the recovery with this DSN, which got created earlier. So these are the real-time figures. So we have run multiple jobs. So we have run the jobs repetitively, and we have taken the averages. So average time, if you compare for a HAL DB with 10 partitions, even though the data looks very low, we have tested varying the data sizes from few MBs to few gigs also, varying with the block sizes and record lengths. So if you see here the CP time for the image copy execution with tape storage, so CP time and active time, you can see the average times here. And then the image copy execution with the cloud. So you can see, although you don't see a much reduction or the difference here, CP time, but active time is reduced significantly. And we have also observed scenarios where we have significant reduction on the CP time also, provided the dedicated resources are present on that particular LPAR, and it also is being affected by the traffic which was present at that time when we were running those jobs. So again, the same stats for recovery here. We have the CP time and active time, and you can see here. So we have reduction in the CP time and overall active time. And if you observe, the zip engines are not enabled here in the traditional JCLs, but when we are using CDS, the zips are enabled here. So yeah, this was the whole scene which we have experienced with CDS. So we have some key takeaways from my experience and the session. Like we have zero disruption, almost zero disruption, we can say. This modernization without application rewrites. Then we have legacy tape semantics and standard IMS workflows. This will remain completely intact. Then we have mainframe FinOps. Then we will be having the cyber resiliency. So achieve near instant RTOs and protect enterprise. And then we have these worm object policies and isolated air gapping present with the architectures. So yes, this was all about the CDS which we have experienced so far. So coming to the last point. So any questions? Maybe I would stop sharing here, and I am, yeah, welcoming for the questions.
There's a something from John in chat.
Okay, one second. The assumption that in the Centrium interface falls between the standard I/O TPTS, that the OS is generalized, this and the same S3 bucket storage can be enabled for physical media, maybe. Yes, yes, John. So, it has again multiple parameters, as I said earlier. So, we cannot be generalizing this thing, but yes, as I said, it depends totally on the software version, then your RTOs, RPOs, your setup, and then what are the policies you have set up at CDS side, the worm policies. So, yeah, ACS routines.
Any other questions? And if you have a question that would be better verbal off mute.
Yes, this is cloud agnostics, provided we haven't tested with that perspective, but definitely we are planning to work more on this side. I mean, we are in a very initial phase of this testing. as I showed in my last few slides in my presentation, it's just a starting point for us. We have just set up the hardware, software, and we just tested our backup and recovery jobs using tapes and then using CDS.
I'm going to go ahead and share my screen, but of course, please put any additional questions you have into chat or raise your hand and we can get you off mute. Um, Thank you, Sujata, for your presentation today. That was great. One common question I get is the recording going to be available? And yes, the recording will be available. I also had a DM during the session for someone who had to drop out early, making sure that they wanted to make sure also that they'd be able to get this. So we'll get this published soon. And if you can share it, we'd love to put the PowerPoint up too as a PDF on the site for everyone. So this will be available to you. And then let's see, news-wise, if y'all are interested, this month at Planet Mainframe, we're talking about investment, technical debt, and business value. So some really great content has been populating the site this week or this month, and I encourage you to check out the Performance and Tuning Month content at planetmainframe.com. And then, of course, you can continue the conversation on LinkedIn. We have all of the videos, in addition to being on our site, are posted on YouTube as well. And which means you can go back and do like all the past videos, which is great. And then I promised y'all the next date. So our next session will be September 1st, when we're going to talk about the system modification program. And it should be a good event. Same time, it's on a Tuesday. And we'll see y'all then. Registration is open for this session if y'all want to go and register for it on Planet Mainframe. You go to planetmainframe.com/IMS should get you there, or virtualusergroups.com will get you there as well. Do we have any other questions before we close out today? Doesn't look like it. Sujata, I want to
Just
thank you.
wondering what your
Okay.
YouTube channel is? I didn't know you had
Oh,
one.
it is virtual user groups. If you search for it, it should be virtual user groups, or it might be mainframe virtual user groups. Or if you, on the screen, the tiny URL right here, or QR code will get you there as well.
Oh, okay. Great. Thank you.
Yeah, no problem. It's also, it should be linked from our website too, if you're having trouble finding it. Again, before we go, I'm A. Henley at planetmainframe.com. Shoot me a note. Let me know what you want to hear about, kind of sessions you'd like to see. And we'd love to get that feedback from you. And then if you have something you'd like to present to your colleagues, that'd be great too. And again, our next event, September 1. In the meantime, I'll be at Share next month, August. Come see me. We've got the Planet Mainframe we'll be exhibiting, and I've got some t-shirts for y'all and other goodies. So with that, I want to thank you all for being here today, and we'll see you real soon.